Let's consider these three inductive arguments. These arguments have a similar general direction, a similar general shape. But when we look at these, they feel different. So the first argument goes, I asked my 4 teenage cousins, and they all used tic-tac. Therefore, tic-tac is popular with teenagers. The second one goes, I surveyed 500 teenagers, and 435 of them used tic-tac. Therefore, tic-tac is popular with teenagers. In the third one, I surveyed 10,000 teenagers, randomly selected from all 50 states, and 8,928 of them used tic-tac. And I concluded that tic-tac is popular with teenagers. Now, these arguments are very similar. They have similar premises. They're all about, I asked a bunch of teenagers and they all like tic-tac. And they have the same conclusion. Tic-tac is popular with teenagers. But they're very different arguments. Argument 1 is probably an example of hasty generalization, because 4 teenagers is a very small number of teenagers to conclude anything about all teenagers from. It might also be cherry picking, at least in some regard, because I only asked my cousins. I only asked members of my family, and if you meet them, you will know that my family are all dorks. That's not actually true. My teenage cousins are actually pretty cool, I think, but of course, I'm also a dork. Argument 2 and 3 seem a little bit less hasty, but argument 3 is stronger than argument 2, since there are more teenagers counted in argument 3. Argument 2 is based on only 500 teenagers. Argument 3 is based on 10,000. It's more likely that I would randomly get a group of 500 teenagers that were all into tic-tac than that I would randomly get a group of 10,000 teenagers that were all into tic-tac. And there are some parts in argument 3 where I talk about the teenagers being randomly selected, and I talk about all 50 states. Those are probably included in the argument in order to show that I wasn't cherry-picking either. So this actually raises a lot of questions about arguments of this kind. We see arguments of this kind very frequently. But in order to make an argument like this, how many teenagers do I actually need to ask? Can my conclusion be a little bit more specific than just tic-tac is popular? If I'm presenting this argument to you, how can you know I wasn't cherry-picking? And when I have an inductive argument, my conclusion is probably true. What does probably even mean? On the level of informal inductive arguments, we can be kind of relaxed about the answers to these questions. We feel like 4 is not enough, but 500 or 10,000 both sound pretty good. But if we want to be more precise about when an inductive argument really is sound and what it really means for the conclusion to be probably true, we turn to the subject of our next unit on statistics. So keep these questions in mind as we move into our study of statistics, because those are the kind of questions that statistics is interested in answering.